Alright, so we can define a vector as, very similar how Vector described himself, a quantity represented by an arrow with two things. What were the two words Vector used to describe himself? Direction and magnitude. You got it. So direction, and we can think of direction as being an angle measure. It's telling us where we're going. And then magnitude. How else did I want you to think of magnitude as? Distance or length, right? And then later, next class, we're going to also look at how this can be described as a force. So here's the two big ideas here. Now I'm going to draw a vector as an example, kind of similar to what you did in that table. So let's say you have the vector AB. You're starting at A, you end at B, and this is equivalent to 3, 2. We can think of us as going 3 to the right and 2 up. So this is like how you walked, right? When you were moving. And this would be the most direct path to it. Alright, now let's take this farther. Do you know the total distance you've traveled? I mean, out there we were walking 3 and we were moving up 2, right? But the vector itself is just represented by this. This is kind of the direct movement. How can you figure out this magnitude? Pythagorean theorem. Go ahead and use the Pythagorean theorem. Figure out your magnitude. And you can leave it as a radical. You guys get rad 13? Okay. So our magnitude is rad 13. So I want to kind of differentiate between the forms. This first form that we just looked at early on, what I gave you, this is called component form. And component form just has your x and your y movement. Does it tell you anything about your length or your magnitude? No, you got to figure that out, right? Standard form, you need two things. You need your magnitude and your angle, right? Do we know what angle we moved at? This is like how Vector described himself. We need our direction, our magnitude. We have our magnitude, but now we need our angle. Talk in your teams. How are you going to find this angle? Dig back to chapter 4 and 6 with trig. Based on this, how are you going to use what you know about right triangles to figure out what theta is? Okay, and you will need your calculators for this. Talk about it. The easiest trig ratio to use here is tangent. And why is tangent the best bet? Van?
Because if you sine or cosine, you're going to have to deal with the rad.
Yeah, opposite over adjacent uses 2 and 3, so that's probably the cleanest way to do this. So we can say tangent of theta is equal to 2 over 3. This is chapter 4. How do we get rid of tan? Tan inverse. Tan negative 1. So take tan negative 1 on both sides. If we're dealing with triangles, what mode do you need to be in? Radians or degrees? Radians. All right. Who's got an angle measure for me? 33.7 degrees. Make sure you type that in your calculator so you get the same thing. And then we're going to say the length of AB, I'll introduce this form in a sec, is rad 13. Alright, so this is your second form. This is called standard form. Or I'm going to refer to it as standard form. We've got to talk about one other thing we haven't mentioned yet. Standard position versus what we call our bearing position, or we can think of this in terms of navigation. Navigation, and then this is the unit circle. And I'll tell you what I mean by this. This has everything to do with the angle. So let's start with what you know. Let's say I have this angle, or this vector. Just this vector. We'll just think of this part, but I'm drawing this so you can kind of measure the angle. And we're going to say that theta equals 135 degrees. Where do you think 0 degrees is when you're dealing with navigation? It's not due east anymore. Where is it?
It's north.
It's north. So now instead of 0 degrees being here, it's right up here, which means, and you would think we would go this way, but we actually end up going clockwise. East is 90, south is 180, and west is 270. So if we get back to north, we get to 360. Now, how's this going to play out? Well, in your project, since we'll be dealing with navigation, you're going to be thinking more in terms of a map. This is the same exact vector, meaning the length is the same and the direction's the same. But if we're dealing with navigation, is this 135 degrees anymore? No, 135 degrees is actually right down here, because this is 90 and this is 180, right? In your teams, I want you to try to figure out what measure this is. Just talk about it. You're kind of going to problem solve. How can you figure out what angle that is? Any questions on this? Okay, you'll get more practice on this.